right, guys, I am going to get started here, and this is kind of exactly what I did for the videos on Monday, so I hope you guys watched them. If not, we're gonna just do all of this today. So like today is just all about practicing ionic compound nomenclature, so that's the front of the worksheet, and then the back of the worksheet is chemical equations, so that going from chemical equations from words into symbols and then balancing them. So this is all we are doing today. It is just covering all of the ionic nomenclature that we were supposed to learn on Monday. So these are the polyatomic ions that I care that you memorized. I know that the video I posted had a couple more. I know it had chromate and dichromate and permanganate. Those three, like, I don't care as much for your class. Those three are kind of more for the upper class. So it's everything else. You do have to memorize them, okay? So I want you to be aware. You must memorize these polyatomic ions. You have to be able to go from the name to the formula to the name. So hydroxide is OH. It has a -1. Bicarbonate, again, your book will call it hydrogen carbonate, and to be honest with you, that's how I caught lots of people cheating when we were going remote. I will never call it hydrogen carbonate. It is bicarbonate, HCO3-. Acetate, that's an important one. We'll use it more when we get into acids and bases. So acetate is CH3CO2-. That's another huge one I catch people cheating with all the time when I was on remote. Nitrate is NO3-, cyanide is CN-. So those are all the -1 anions that are polyatomic. Many atoms together that overall have a charge. That's what polyatomic ion stands for. Carbonate is CO3-2-. This is a frequent place where students get confused, so just be aware. Bicarbonate is HCO3 with a -1 charge. Carbonate is CO3 that has a -2 charge. So they are absolutely related to one another. Bicarbonate is HCO3 with a -1. Carbonate is CO3 with a -2. Sulfate is SO4 with a -2. Phosphate is PO4 with a -3. And then ammonium is NH4 with a +1. And hydronium is H3O with a +1. So these are the 10 that I care about for your class that you absolutely have memorized. Name to formula, formula to name. You have to be able to use them and go back and forth. All right. So hopefully it's in your notes now if you didn't take notes from the video, which I apologize. Some of those videos were a little rough. I did the best I could. Okay, so now I just want to jump into it, okay? So this is what the table, and every exam from now until the end of the semester will have a table, and it will be at least 10, formula to name, name to formula. This is going to be actually, I know this sounds bizarre, but this is actually going to be the easiest iteration of this table. This table will only get harder for exams 2, 3, and the final. This one is the easiest because you know that they are all ionic compounds. I haven't talked about anything else. So at the very least, what you know about all of these compounds is that they are all ionic. So we're just going to jump right into it. And I'm going to walk you through how I think about these things. And to be honest with you, Fe2S3 is the hardest kind that I can give you. So the first thing, if we go from the formula to name, you have to figure out, is it a main group metal? So the main group metals are the metals that are only in the S block of the periodic table. Those are the main group. Every element in group 1 will always have a +1 charge. Every element in group 2 will always have a +2 charge. Those ones are known. The transition metals, they go from where the D block starts all the way over to the staircase. These are called the transition metals. The transition metals have variable charges, except aluminum. Aluminum is totally an exception. For a lot of different reasons, aluminum is an exception. Aluminum is always +3, but everything else has variable charges. That includes lead. Sometimes I get students that forget that lead is a transition. Lead absolutely has variable charges. And same with tin. Tin is SN above lead. Both of these guys are transition metals. They have variable charges. So the first thing when we have Fe2S3, Fe is a transition metal. That means you have to give the charge in Roman numerals. So if it's a transition metal, it has a variable charge, you have to give it in Roman numerals. So we know right away that this compound is going to be named iron something sulfide. The cation comes first, the anion comes second, it changes its name. We know it's going to be iron something sulfide. Now it's our job to figure out what the charge on the iron is. This is where I recommend that you break it down into its pieces. This subscript of, oh, it's going to be a long day. This subscript of 2 here means that we have 2 iron ions. So that subscript of 2 tells us that we have 2 iron ions. So I'm going to write that as 2 Fe. We know it's going to have a positive charge because iron is a metal. Metals make cations. We don't know what its charge is, but that's what we're trying to figure out. But we know it's going to be positively charged. Then this subscript of 3, it did not do this during my first class. I don't know what I'm hitting. Oh, I see. Okay. This subscript of 3 on the sulfur means that we have 3 sulfide ions. So we have 3 sulfide ions. So now we got to figure out what is the charge on the sulfide ion. So it's based on sulfur. Sulfur is here in group 6. So how many valence electrons does sulfur have? 6 of them. Good. Sulfur is in group 6. So it has 6 valence electrons. So it's going to gain 2 electrons to look like a noble gas. So if sulfur gains 2 electrons to look like argon, what is the charge on a sulfide ion? -2. Beautiful. So now the whole point of having an ionic compound is that the positive part and the negative part equal out to be 0. It has no overall charge. So over here we have 3 sulfides. That gives us an overall -6. That means over here this has to have a +6 because +6 -6, that equals 0. But we have 2 of them. That means the charge on each individual iron is +3. Good job, friends. So the way we say this is iron 3 sulfide. So it's iron with Roman numeral 3 after it and then sulfide. Does that make sense-ish? Let's do the next one, which is CrCl3. CrCl3. First thing is really, is it ionic? For you guys, the answer is yes. That eventually will not be the case. Eventually, you will have either ionic, covalent, or an acid. Right now, they're just ionic. We haven't talked about covalent compounds, so we know it's ionic. So now the next question is, okay, where's chromium? Chromium is here. That means that chromium is a transition metal. Since chromium is a transition metal, you have to give me its charge in Roman numerals. So this is chromium something chloride. We've got to figure out what the chloride, because chlorine, and when it gains an electron to look like a noble gas, it changes its ending to IDE. So this is chromium something chloride. Chromium is going to be positively charged. All metals make cations. So it has to have some kind of positive charge. This subscript of 3 tells me that I have 3 chloride ions. What is the charge on a single chloride ion? What's the charge on it, though, after it looks like a noble gas? -1. It gains an electron. Gaining an electron makes you sad. Oh, fair enough. You're golden. So it has to gain 1 electron, so its charge is -1. You guys are right. It has 7 valence electrons. 7 valence electrons. It gains 1 to look like a noble gas, so overall it has a -1 charge. So that means that overall the portion of our molecule is -3. That means that the positive portion of our molecule it's not a molecule. This is really technical, just so you guys are aware. Molecule is technically only for covalent compounds, but it slips out every now and then when I'm talking about ionic compounds as well. They're not technically molecules. They're technically formula units, but anyways, we have a -3 portion of the compound. That means that we have to have a +3 portion of the compound to balance that out. So what is the charge on the chromium? +3, good. And so the name for this compound is chromium 3 chloride. Better? Making sense? Good. Iron 3 carbonate. Now we're going from name to formula. Going from name to formula, I always recommend that you go back to the ions. It is an ionic compound. Iron is a metal. That means it's a transition metal. That's why it has that 3 in Roman numerals. So that means that we have iron that has a +3 charge. Carbonate is one of the polyatomic ions that you just have to memorize. So if you notice, one thing that's different about carbonate versus all the other ions that we've done so far is it's ATE. All of our other ions have been IDE. That's kind of a sign to you that it's one of the polyatomics. That's not always the case, but that's a hint. So carbonate is one of the polyatomic ions that you just have to memorize. And I just so happen to know that it's CO3 and it has a 2- charge. So iron 3 carbonate is comprised of the iron 3 and the carbonate ions. Now, again, this one's tough. I really, honestly, and truly, I wouldn't lie to you about this. I can't get much harder than when we have a 3 and a 2. It doesn't get much harder than that. So we have iron that has a +3. We have carbonate that has a -2. What is the ratio that I'm going to bring those guys together such that overall it has a 0 charge? So how many irons to how many carbonates? What is that ratio? Oh, someone's got it, I'm sure. Does anyone want to take a guess? 2 to 3. Beautiful. So we have iron with a subscript of 2. And then we need parentheses for carbonate in a subscript of 3. How I knew that is the least common multiple is 6. So we're going to get this side down to -6. That means I need 3 of them. I'm going to get this side up to +6, which means I need to have 2 of them. So it's Fe2, and then in parentheses, CO33. That's telling me that I need 3 of those things that function as a unit. So 2 iron ions and 3 carbonate ions, the whole thing together. Good? Fabulous. Potassium oxide is one of the straightforward ones. Potassium is one of the main group metals. Potassium is in group 1 of the periodic table. So what is the charge on a potassium ion? I gave it to you already. What's the charge on a potassium ion? +1. It has 1 valence electron. It loses that 1 valence electron. So potassium has a +1. What's the charge on an oxide ion? -2. It's in group 6. So it gains 2 electrons to look like a noble gas. When you gain 2 electrons, you become negatively charged. So oxide has a -2 charge. So what is the ratio that I bring them together? How many potassiums to how many oxides? 2 to 1. So the chemical formula is K2O. Aluminum iodide. Aluminum, again, is tricky. We deal with it in the lab a lot. You're going to see it often, but students forget it all the time. Aluminum's here on the periodic table. So you might be like, well, Dr. L, that's clearly a transition metal. And I'll be like, no, it's not. I'm really sorry. Aluminum is absolutely an exception. It always will have a +3 charge. So aluminum is an exception. Even though it looks like a transition, it's really technically a main group metal. And that's because it has no D electrons involved. It doesn't matter. But aluminum is an exception. Aluminum has 3 valence electrons. Aluminum will lose those 3 valence electrons to look like a noble gas. So aluminum is always Al +3. What is the charge on an iodide ion? So iodine is a halogen. It's in group 7. What's the charge on an iodide ion? -1. So what is the chemical formula for aluminum iodide? chemical formula. Ali3, beautiful. We have Ca3P. Calcium is one of the main group metals. It always has a particular charge. It does not require Roman numerals. So this is why things get tricky. Sometimes students are just like, well, everything needs a Roman numeral. It doesn't. Calcium's a main group. It's always +2. Doesn't need a Roman numeral. Phosphorus is in group 5. It gains 3 electrons. It doesn't matter. When we go from the formula to the name, all you tell me is what is the cation, calcium, and what is the anion, phosphide. So this guy is calcium phosphide. And then we have AgF. So first thing, it's ionic. Second thing, silver is here. Silver is a transition. Since silver is a transition, you got to give me its charge in Roman numerals. So we know it's going to be silver something fluoride. We just got to figure out what its charge is. When you go to figure out what its charge is, you break it into its ions. Silver is going to have some kind of positive charge because it's a metal. Metals make cations. Fluoride is a halogen. It's going to have a -1 charge. So overall, we have a -1 portion of the compound. So we have to have a matching +1 portion of the compound in order to even that out to 0. So what is the charge on a silver ion? +1. So it's silver 1 fluoride. Better now? All right, I'm going to give you guys some time now that we went through and did that, and I'm pretty sure we have all of the examples. Transition metals, non-transition metals, polyatomic ions. I'm going to stop and give you guys some more time to work on the rest of it to see if that kind of gave you a push in the right direction. So I'll give you 5 minutes or so, and then we'll come back and finish that up. I'm going to leave the polyatomic ions up here up front just in case you need to glance at it, write it down. And then I'm going to